Okay, hello Cloud Gurus and welcome to this last lecture in the EC2 section of the course. Well, congratulations ladies and gentlemen, you have made it through this section. This is a fundamental topic for your exam. It will come up time and time again. In fact, EC2 comes up in all 8 certification exams because it's one of the very bedrocks of Amazon Web Services. So you've done really well. Let's go through and summarize what it is you've learned in this section. Please do remember to go and read the EC2 FAQ before attempting any AWS exam. So going into the exams, what do you need to know? Well, you need to know the difference pricing models for EC2. So you need to know the differences between on-demand, spot, reserved, and dedicated hosts. And what they'll do in the exams is they're going to throw you a whole bunch of different scenarios, and then they'll ask you to choose the best pricing model to suit that scenario. So it could be that you're a genomics company or a pharmaceutical company who have a huge compute requirement, but they need to minimize costs and they can time this for, I don't know, 2 a.m. in the morning. What would be the best option there? And it might be that they can afford to have their instances terminated. They design their application so that it all stores in S3 any data that's processed. So that would be a perfect example for using spot instances because you want to minimize your costs. You can take advantage of it when the costs are really low, when demand is really low. So you might want to use spot instances there. Might be another example whereby you've got a fairly steady state web application with 10,000 users, doesn't spike a lot, but you need to minimize costs. What should you do? In that case, you probably want to use reserved instances. Might give you a scenario where you've got a Black Friday sale coming up and you just need to scale for a 72-hour period and then scale back down again. Well, that would be on-demand instances. And then you might get a scenario where maybe a regulatory body says that you must not have multi-tenant you'd be using multi-tenant compute. In that case, you'd want to be using dedicated hosts. So just understand the different pricing models, and you should do really well in those scenario-based questions. Also, remember with spot instances, there's a really sort of key difference here. So if you terminate the instance, you're always going to pay for the hour. So let's say I've had a spot instance running for 2.5 hours and I terminate it halfway through. That's third hour, I'm going to pay for 3 hours in total. But if AWS terminated it because my spot price went above my bid price, then you're going to get that hour that it was terminated for free, so you'd only pay for 2 hours. So do remember those key differences going into the exams as well. So moving on to EC2 instance types, if you can still remember my dodgy anagram or acronym, see if you can name them all to yourself. If not, keep practicing. I keep saying in that particular lecture in EC2 101 that you don't necessarily have to know every single EC2 instance types going into either the Solutions Architect Associate or the Developer Associate exam, but all other exams it is really, really crucial that you do know the differences, the different instance types. And to be honest guys, if you're going to be working with AWS and you really want to know what you're talking about, you should always know your different EC2 instance types. So it is a really valuable thing to learn. So we used the anagram or acronym Dr. McGiftpicks, and we'll come to him in a second, but let's just have a look at what each one does. So we had D for dense storage, and this is use cases for file servers, data warehousing, Hadoop, etc. We then had memory optimize, R, which I like to remember is for RAM, memory intensive apps and memory intensive databases. We then had M4. M is just general purpose applications, typically your application servers, and you use M if we typically use T2 micros throughout every lab in this course, but M is what you would use in production. So it's an all-round so it's a good all-round virtual machine. We then have C's, which stands for compute optimized. So this is going to be your CPU intensive apps and databases. We then have the G family, which is graphics intensive. Really G, the difference between G and P is G is where you're doing video encoding and application streaming, whereas P is more for things like machine learning or Bitcoin mining. So G is really about graphics. And moving on to I, so we've got IOPS. This is your high-speed storage. So this is for NoSQL databases, data warehousing, warehousing, etc. We've got a new instance type, which is called Fs, which is for field programmable gate arrays, and this is hardware acceleration for your code. Very, very new, just came out at reInvent 2016. We then have Ts, which is what we've been using throughout this whole course, so T2 micros, just remember that. They're the lowest cost general purpose servers, usually used for test and dev, and they make great little web servers and small database servers. Then have Ps, again P stands, I like to remember it as pitches, so it's general graphics but also general purpose GPU, so really it's about machine learning, Bitcoin mining, that sort of thing, although it will never say Bitcoin mining in the official documentation, but you know, that's what people do use. And then we have X1s, and I like to remember X as extreme RAM, so things that are super RAM heavy, things like SAP HANA or Apache Spark, etc. These are memory optimized instances. So here we go, here's my Dr. McGift pics. So here he is, he's clearly a doctor. I don't know how, maybe because he's got the glasses on or something. He's clearly Scottish, so that's why he's got the Mc. But instead of selling burgers like McDonald's, he sells pictures, or he actually doesn't even sell them, he gives them away, gives away pictures of Scotland. I know it's not brilliant, guys, but you know, it's going to stick with you in the exam, and if it gets you a few extra bonus marks and there's a difference between you passing or failing your exams, then I'm completely unapologetic. Moving on to EBS, so we looked at the different EBS volume types. So we have SSD, which is general purpose, and this is up to 10,000 IOPS. This is what we use basically all the time in the labs. We then have SSD provisioned IOPS. So the use case for this is more than 10,000 IOPS, and you get up to 20,000 IOPS per volume right now. Now this could change throughout the year. You're never going to be tested on, you know, how many regions are there in AWS, or how many IOPS can you deliver for provisioned IOPS, etc. You're never going to give these like maximums. You're never going to be asked for a particular figure. What's important is you understand the use cases. We then have HDD throughput optimized. So this is where we're doing sequential writes. So this is frequently access workloads, usually used for data warehousing, for example, transaction logging, that sort of thing. We then have HDD code, which is called SC1. And this is less frequently accessed data. Typically you use these for file servers. Remember that ST1 and SC1 cannot be used as boot volumes. They can only be additional volumes attached to your EC2 instance. And then we have HDD magnetic standard, which is essentially the same as HDD cold, except you can have it as a boot volume. So this is your cheap, infrequently accessed storage. Could be your test and dev servers while you're building out your AMIs and you want to keep costs low. It's entirely up to you. And then my final tip on EBS, remember you cannot mount an EBS volume to multiple EC2 instances. If you want to share, you know, basically block level storage between EC2 instances, then you're going to be using EFS as opposed to using EBS, and we saw that in the labs. Okay, so moving on to EC2, what did we learn in the labs? Well, we learned that termination protection is turned off by default. You must turn it on. On an EBS-backed instance, however, the default action for the root EBS volume is to be deleted when the instance is terminated. So that's the root EBS volume. By that, we just mean the volume in which the operating system is installed. If you go in and terminate your EC2 instance, it is by default going to delete that root device volume. However, you can turn that off. So you could go in and terminate your EC2 instances, but still keep the volume in which the OS is installed. Root volumes cannot be encrypted by default. You need a third-party tool, such as Windows BitLocker, for example, to encrypt the root volume. However, additional volumes can be encrypted, and we saw that in that lab. Moving on to volumes and snapshots. So volumes exist on EBS, and they're basically virtual hard disks, and that's all we mean by volumes. And snapshots exist on S3, and they're point-in-time snapshots. So you can also take a snapshot of a volume, and that's going to store that volume on S3, and snapshots are point-in-time copies of the volumes. Snapshots are incremental, and this means that only the blocks that have changed since your last snapshot are moved to S3. So for that reason, it's always going to take you a fair bit of time to do your first snapshot, but then as you take a second or third, only the changed data would be moved to S3. So again, bear that in mind when you're architecting. If it's your first snapshot, it's going to take some time to create. Moving on to volumes versus snapshot from a security perspective. So snapshots of encrypted volumes are encrypted automatically. Volumes that are restored from encrypted snapshots are encrypted automatically. And you can share snapshots, but only if they are unencrypted. You can't share encrypted snapshots. So if you've got any encrypted volumes, then you're trying to take a snapshot of it, just remember you can't encrypt, you can't share that volume. And these snapshots can be shared with other AWS accounts, or you can make them public in the marketplace. Okay, so moving on to snapshots of root device volumes. To create a snapshot for an Amazon EBS volume that serves as a root device volumes, you should stop the instance before taking a snapshot. So that's really important to remember. EBS versus instance store. So we covered this off in a lab and a theoretical section. So instance store volumes are sometimes called ephemeral storage. Instance store volumes cannot be stopped. If the underlying host fails, you are going to lose your data. So just remember that. You can reboot instance store volumes, however. EBS-backed instances can be stopped, and you're not going to lose the data on the instance if it is stopped. And you can reboot both, and you're not going to lose your data. By default, both the root volumes will be deleted on termination. However, with EBS volumes, you can tell AWS to keep the root device volume. So again, it's coming back to that same point I made in a couple of slides ago. By default, your root device volume for EBS will be deleted on termination. If you go in and terminate that EC2 instance, it's going to terminate the EBS volume automatically. However, you can set a flag to say don't delete it, but only for EBS backed volumes. You can't do that for instance store volumes. So if you terminate an EC2 instance that has an instance store volume, you're gonna lose all your data on that volume. Moving on to how we can take a snapshot of a RAID array. So there's a problem. Basically, if you're taking a snapshot, the snapshot's going to exclude the data held in the cache by applications in the OS. And this tends not to matter on a single volume. However, if you're using multiple volumes in a RAID array, it can be cause a problem due to interdependencies of the array. So what's the solution? Well, we have to take an application consistent snapshot. So how do we actually do that? Well, we need to stop the application from writing to disk. We need to flush all the caches to disk. And how do we do this? Well, there's three ways to do it. We can freeze the file system. We can unmount the RAID array. And the easiest way is to shut down the associated EC2 instance and to take our snapshot after it has been shut down. But essentially, all you're trying to do is stop any kind of I/O, input/output being written or read from that RAID array when you're taking the snapshot. That's how you take a snapshot of a RAID array and make it application consistent. So again, important to remember that going into the exam. Amazon machine images, so it's a couple of exam tips, or just one actually. AMIs are regional, so you can only launch an AMI from the region in which it is stored. You can copy AMIs to other regions using the console command line tools or using the Amazon EC2 API, however. Moving on to CloudWatch, so your standard monitoring is enabled by default for EC2, and it monitors events on a 5-minute basis. You can enable detailed monitoring, and then it will enable your events every 1 minute, but you do pay extra for that. CloudWatch is for performance monitoring. Just remember that. Don't confuse it with CloudTrail. CloudTrail is for auditing. And again, that's a popular sort of scenario question. They'll throw a scenario at you and say, should you be using CloudWatch? Should you be using CloudTrail? Should you be using something else? So just remember that CloudWatch is for performance monitoring and CloudTrail is for auditing. So what can you do with CloudWatch? Well, you get your dashboards, so you can create those awesome dashboards with all the different widgets and see what's happening in your AWS environment. You can create alarms, so these alarms can notify you when particular thresholds are hit. You can also use those alarms for auto-scaling events. You can create events, so CloudWatch events helps you to respond to state changes in your AWS resources, and then you can also send your logs to CloudWatch. So CloudWatch logs helps you to aggregate, monitor, and store your logs. In terms of roles, what did we learn in the roles lab? Well, roles are really awesome. They're much more secure than storing your access key and secret access key on individual EC2 instances. Roles are much easier to manage from a security perspective than having all these access keys and secret access keys out there in the world. If you lose one, you have to disable them. Then you have to go and run AWS configure on all the different EC2 instances that you might be using the command line tools on. So roles are much easier to manage. and roles can only be assigned when that EC2 instance is being provisioned. You can't assign a role after that EC2 instance is being provisioned. But on top of that, though, you can change the permissions to a role at any time, and those changes take effect immediately. Roles are also universal, so you set up a role, doesn't matter if you're in Ireland or in California, you will be able to use that role wherever you are in AWS. Going on to instance metadata, this is basically used to get information about an instance. So as we saw in that lab, it could be the public IP address, could be the private IP address, etc. And we did that using this command. So it was curl http, and then you should really remember this URL. So it's 169.254.169.254/latest/metadata. There's no such thing as user data for an instance, and we proved that by trying to curl the same URL but with user data at the end. And moving on to Elastic File System. So basically, Elastic File System is brand new. It supports NFS version 4. You only pay for the storage in which you use. You don't have to pre-provision, as we saw in that lab. So you don't have to say I need an 8 gig instance. You literally just start writing to EFS, and you're going to pay at this stage 30 cents per gig. You can scale up to the petabytes. It can support thousands of concurrent NFS connections. Data is stored across multiple availability zones within a single region, and it's very similar to S3 in that it has read after write consistency. So as soon as you put a new object onto EFS, you'll immediately be able to read from it. One thing I will say though is because EFS is still only within Oregon at the time of recording, and it is still in preview, this will not come up on the exam just yet. However, it's important that you do have a good knowledge of it, because I would place a bet that it's going to be included on the 2016 exam at some point in time. And if you do see an EFS question on your exam, please write to us and tell us. Okay, and then we had Lambda, and Lambda again is fairly new technology. We at A Cloud Guru love Lambda. Our entire school runs off Lambda. Saves us a fortune in hosting costs. We're completely serverless. So Lambda is a compute service that you can basically just upload your code and create a Lambda function, and then AWS Lambda takes care of the provisioning and managing the services that you use to run that code. So you don't have to worry about things like operating systems, patching, scaling, etc. You literally just put your code up into the cloud and it will run. So you can use Lambda in the following ways. As an event-driven compute service, this is where Lambda basically runs your code in response to events. So these events could be changes to data in an S3 bucket or a DynamoDB table. And I gave the example of, somebody uploads a picture to an S3 bucket using your web application. Lambda then goes in and maybe moves that picture over to another bucket. It might watermark it. It might do, a whole bunch of series of different things. You can also use Lambda as a compute service to run your code in response to HTTP requests using the API gateway or API calls using the AWS SDKs, and that's exactly what we do at A Cloud Guru. So if you are watching this on the A Cloud Guru platform or on your mobile device or laptop, you are literally interacting with Lambda as we speak. So that's it for this lecture, guys. If you have any questions, please let me know. This has been a long section, but it is a really important section for the exam, and I'm sure you've learnt an awful lot. But that's it. Thanks a lot, guys, and I'll see you over in section 6. Thank you.